Hi all, welcome to another episode of Saturday Architecture. Today I just realized that after having been in architecture for more than 2 decades, I realized that I just can't develop AI solutions with the knowledge from these 2 decades of architectural experience. In fact, you develop a very poor AI solution, and wanted to ask Deepak what his experience is around and how he's also been around for 2 decades. What does he consider a different approach to developing AI solutions, and why the current way of doing things and testing and getting requirements and having a dev team, all that way things which is needed to make a big solution won't really fly. Why would that be? And Deepak, what is your thoughts around that?
I think the problem is twofold. One is that the architects don't really understand the power of AI at this point of time. Most of them believe that it is something which is obscure, or maybe it can generate some stories, or maybe it can generate some interesting stuff, but I can't really use it for my application. That is one, right? The second is the traditional knowledge which they have about developing software is obsolete for, or I would not say obsolete, it becomes, it you
The
cannot really,
relevance has become less. The relevance has become less. Direct
relevance has become
relevance.
less, or you cannot directly apply the same principles what you used to apply in the traditional software development world, where you could write the business case and have a deterministic test and have the same result appear over and over again on software. And this also raises this whole set of new challenges for software testing, right? Now, the thing is, how do you relate it to what we already know? So the good news is we already know how to work with AI system, work with imperfect systems, right? So because the main thing is AI is a non-deterministic, imperfect system, and anyone who has used ChatGPT knows that ChatGPT can give you wrong answer at least 25% of the time. Maybe I do not know, the number may be
What
higher.
impacts imperfect systems do we know to work with? I don't under. What do you mean? Can you expand on? What do you
So
mean by we already know
yeah, so
about
imperfect
imperfect
systems
systems?
means the systems which will given the same input may not give the same output, right? So, okay, let me give you an analogy of how we already know how to do this, right?
Okay.
Human beings are imperfect, right? All of us know that, and
Yeah.
and we teach human beings all the time, right? So we are teaching human beings, are giving them knowledge, and we are preparing them for the world to go and solve problems. And so in that sense, each human being is a very complex software program which is non-deterministic in itself, right? And the results are unpredictable, but still we spend a lot of effort in training them, right? Which is what we intend to do with the AI also. You train the AI system, which is analogous to what we are doing with human beings, except that let us leave out the consciousness debate outside. But in terms of being able to gather the knowledge from different sources and be able to apply that knowledge together in a creative way, AI systems have come very close to what human beings actually do. And we already know that two human beings solving the same problem, you will get two different approaches and get maybe close enough results, right? Maybe the results of the, so if you were to test, now let us take the analogy further, that you give the same knowledge as a teacher. You are teaching the same subject to all the students
Or
in a
can
30
we?
people
Can I
classroom. Yeah.
just to understand this? Can I say that, let's say we call two senior team members, very experienced folks, okay,
Yes.
and ask them, give them a case study, right? And we have seen that, and ask the professor asks them, or the boss asks them, do analysis of this company and come out with a presentation. In all probability, both the senior folks will give something different. The
Yes.
format, the content, the approach. So that's
Yes.
what you're trying to say. Even within a system, it will
Yes,
become different, is what you're trying to say. It won't be same consistent result, or I do it the second time, I will do it differently, not like how I did it the first time.
exactly,
Okay.
exactly. Yeah. So
Okay.
that is something which is very clear that we know, and we are used to this part, right? Now this is where the architects need to apply this analogy to testing of their systems, and being flexible to account for this kind of imperfection, right? So this imperfection is inbuilt into human beings. This imperfect is inbuilt into the current AI implementation. So that's why that's why you have the regenerate answer option in chat gpt as well. And every time it regenerates, you get a slightly different version of the same thing. And that's how human beings work, right? It's like asking a different person the same question, right? Now the difficult part is how you are going to apply all these things into creating a viable method of applying it to software development, right? How do you make something acceptable? How do you test it? So these are new challenges. Now,
So
this, what,
when you say how you tested, conventionally we have been testing, is this right or wrong? Okay. Is this answer right? Is this, is it right or wrong? It's just a question of right or wrong, zero or one, test case passed or fail. Now,
right?
from what you are telling, it has moved to, is it 100% wrong or is it 70% wrong? It's not a digital yes or no answer.
Correct,
So,
correct.
how do you shift your? So, it's not about a test case passing or failing. It is a question of how much of the test case, is it 80% correct or 70% correct? So, how do you actually approach that shift in thinking as a
Yes,
program manager, project manager, business user? Everybody has to change it. So, what are your
I
thoughts
think
around that?
I think we are too early stage to actually apply that concept, right? So although I said we know how to do this, but I don't think we have evolved a method by which we can safely say, I'm not going to say 100% say, because we can safely say that this system actually works, right? So that is the challenge which we have. So that's why
Or
this
also
is,
to kind of, when you say safely works, right? Probably understand the reality which has been staring at our faces and we fail to acknowledge that there is nothing called a perfect system and we won't
yes,
get it. So
yes,
this kind of gets us closer to reality and then say, okay, it is fair enough. How do you learn to work with the impact perfect system? Probably AI is actually helping us getting more closer to reality, and that shift in thinking is what we need to get to as an
and
architect. So far,
I think for a very long period of time, computer science has always been an exact science, right? You give an input, you get an output. This is how it works. You have a perfect test, everything. Now the paradigm is slowly changing, and I want to sort of relate it to,
so just like science, medicine is also science, computers is
yes,
also science. Okay,
yes,
but an engineer and a doctor think very differently.
exactly,
Probably we need to start
exactly.
becoming more of a doctor than as an engineer. There is no guarantee on what
So
you will
there,
get, but still you work towards that.
even in engineering, for example, we know exactly when certain material breaks, right? We know strength of a material, we can test it, we can put all those complex things into a car, right? We test every material, every piece of steel, every piece of whatever other materials are, we know exactly how those things work. But still, mechanical engineers over engineer their things. They are not never made to specification, right? They are made sometimes two times the specification, which is like, we know this component will be experiencing x amount of stress, but we will build it for 2x stress,
Mm,
right?
mm.
Because we do not know in a complex system how this thing will behave. In spite of that, systems fail, right? So now that concept has to be brought into where is the tolerance? We call it the tolerance, right? What is the tolerance of this system? What, how much, you, how, perfection even in physical world is very difficult, because you cannot machine something to 1 micron, or you want the precision to be 1 millimeter is enough, or 1 micron is enough. So that tolerance between 1 micron and 1 millimeter, that is where this has to be honed down. That what is that an AI system, what is the tolerance we are able to accept, and engineer that system to that tolerance, right? So that is a more approachable solution to get into the tolerance discussions. Then maybe apply it to the medical principles, which are which are even more widely varied, right? Because human bodies are much more complex systems than computer systems or even AI systems, right? That's why medicine always struggles to get you the precise answers to everything. So I would not say go towards medicine right now, because that is much more, I would say, heuristic, right? You need to apply much more heuristic to medicine than you need to apply to solving computer science problems. And
Nice.
it's not that we don't know about heuristics, right? Even today, if you talk about things like an antivirus program, right? Antivirus program works on the principle of heuristics, right? They don't know that every malicious piece of software there, but they work on how it is behaving, right? So they know already this heuristics approach is understood within computer science, but I don't think this is widely understood as a concept for enterprise architects or software system architects, that they can apply this heuristics approach to building software too. So
Nice.
in very narrow domains, heuristics is understood, but in a larger domain, in an interconnected system with unpredictable inputs from various parts, we don't really know what is the precise answer, how we are going to solve it. So I think there needs to be some new thought around how do you solve this problem of unpredictable input output.
Interesting. I think that gives a lot of food for thought. So, as architects, I think we should start looking at it and learning, do a lot of unlearning if we want to get into the space of this. Otherwise, I see that my own experience is actually a limitation to how much I can do. And if I try to make a AI solution which is 100% correct, I would never get it right, because I will just be swinging from one end of right and wrong. For one use case, it will work, another it will fail. So I think it's to curb that instinct and learn more. Hope others found it useful. Please go ahead and share your thoughts and point of views on what you think about what is said and how we can handle this and become better architects for AI solutions. Thanks for joining. Next time.